You're listening to SpaceTime, Series 20, Episode 47. Coming up on SpaceTime, our nearest brown dwarf stellar system, another challenge to the standard model of particle physics, and blast-off for India's new heavy-lift rocket, which will one day carry the nation's first manned spacecraft. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have failed to find any planets orbiting a brown dwarf in the third nearest stellar system to Earth. The search was undertaken by scientists using NASA's Earth-orbiting Hubble Space Telescope. Earlier observations using the European Southern Observatory's VLT, the Very Large Telescope in Chile, indicated the possible presence of an exoplanet in the Luhman 16AB system. However, the new Hubble observations found no evidence for the planet. Luhman 16AB is located just 16.5 light-years away in the southern constellation Vela. Only the Alpha Centauri triple star system and Barnard star are closer. Despite its proximity, Luhman 16AB was only discovered in 2013 by astronomer Kevin Luhman from Pennsylvania State University. The system was originally detected by NASA's Earth-orbiting Wide Field Infrared Survey Explorer, or WISE spacecraft, which searches the sky at infrared wavelengths. The reason it hadn't been noticed before was because the Luhman 16 binary system is located close to the galactic plane of the Milky Way as seen from Earth. Consequently, the two faint brown dwarfs which make up the system were difficult to detect against the densely packed star-filled background. The system was originally named WISE J104915.57-531906.1, but was renamed so as to give the third nearest stellar system to the Earth a more appropriate name than a phone number. The two brown dwarfs which make up the system, Luhman 16A and Luhman 16B, orbit each other every 25 Earth years at a distance of about 3 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. Brown dwarfs are failed stars. They fill the gap between the largest planets, with at least 13 times the mass of Jupiter, and the smallest stars, known as spectral type M red dwarfs. Generally speaking, brown dwarfs don't have enough mass to maintain core hydrogen fusion, the process which makes true stars, like the Sun, shine. However, higher mass brown dwarfs can undertake some limited core hydrogen fusion early in their lives as spectral type M red dwarfs. And brown dwarfs above a certain mass range are thought to fuse lithium and deuterium. The primary in the system is a spectral type L brown dwarf, while the secondary is a spectral type T. The new Hubble observations examine the slow gravitational waltz of the two brown dwarfs over a 3-year period. Astronomers tracked the two components of the system as they both moved across the sky and danced around each other. The team were looking for possible gravitational influences caused by a planet in the system. However, the Hubble data showed that the two brown dwarfs are indeed dancing alone, unperturbed by any massive planetary companion. This is SpaceTime. I'm Stuart Gary. Scientists say they're puzzled by the results of 3 particle physics experiments which are providing glimpses of new physics beyond the standard model, the foundation stone of science's understanding of the universe. The standard model of particle physics describes and predicts the behaviour of all known particles and forces in the cosmos. A report in the journal Nature claims the studies are all finding science contradicting what's known as Leptin Universality. Leptons are charged elemental particles that include electrons, as well as their more massive but shorter-lived versions called muons and taus. Leptin universality is a fundamental assumption of the standard model, implying that the interactions of these particles are always the same, despite their different masses and lifespans. Precision tests comparing processes involving electrons and muons haven't revealed any definite violations of this assumption. However, recent studies of the higher mass tau lepton are producing observations that are challenging the theory. The new review of results from the 3 experiments points to a strong possibility that lepton universality, and perhaps ultimately the standard model itself, may need to be revised. One of the study's authors, Manuel Franco Sevilla from the University of California, Santa Barbara, says the new research found something beyond the standard model during experiments being conducted by the Department of Energy's National Accelerator Laboratory at Stanford University. He says while the discovery was significant, he wouldn't classify it as being definitive. However, similar results have also been seen in the recent Bell experiment in Japan and in research undertaken by the Large Hadron Collider B detector, the LHCb, at CERN, the European Organisation for Nuclear Research. According to Franco Sevilla, the three experiments taken together demonstrate a stronger result which does challenge lepton universality with a 4 sigma level, and that means a 99.95% certainty. Physicists usually only make claims when they have a 5 sigma level of certainty. 5 sigma would mean only one anomaly in 3.5 million runs. All three particle detectors were studying beam mesons, unstable particles that result when powerful particle beams collide, so their properties and their behaviours can be measured with a high precision in a clean environment. And all three experiments, which were measuring the relative ratios of beam meson decays, posted remarkably similar results. They all found the rates of some decays involving the heavy lepton tau relative to those involving lighter leptons, electrons and muons were higher than the standard model's predictions. Franco Sevilla says the tau lepton's key. That's because the electron and muon leptons have already been well measured and studied. But taus are much harder to study because they decay far more rapidly. Franco Sevilla says now that physicists are able to better study taus, they're seeing that perhaps lepton universality isn't satisfied in the way the standard model claims. While intriguing, the new results are not considered sufficient to establish a violation of lepton universality. To turn over this long-held physics precept would require a significance of at least 5 standard deviations. That's 5 sigma in particle physics speak. However, the fact that all three experiments observed a higher than expected tau decay rate, while each was operating in a different environment and under different conditions, is considered highly noteworthy. A confirmation of these results could be pointing to new particles or interactions, which would have profound implications for our understanding of particle physics. Franco Sevilla admits he's not quite sure what confirmation of these results will mean in the long term. He says first scientists will need to make sure the results are correct, and then they'll need to carry out ancillary experiments in order to determine the meaning. You're listening to SpaceTime. I'm Stuart Gary. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at Spacetime with Stuart Gary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. India has launched its most powerful ever rocket. The latest version of its GSLV or Geosynchronous Satellite Launch Vehicle, the GSLV Mark III, blasted off on its first operational flight from the Satish Dhawan Space Centre on the Bay of Bengal coast. The mission also marked the heaviest payload ever launched by India, the 3.2-tonne GSAT-19 telecommunications satellite. The new GSLV Mark III launch vehicle more than doubles the lifting capacity of India's growing space program, allowing it to compete for the first time with Falcon 9 and Soyuz launches on an equal footing. The GSLV Mark III also provides the Indian Space Research Organisation ISRO with the muscle it needs to undertake future manned missions in space. The launch vehicle blasted off using only its twin 25-metre-long strap-on solid rocket boosters, leaving the core stage to ignite 2 minutes into the flight for a 3-minute burn.
Minus 30 seconds.
Real-time programs activated.
Minus 30 seconds.
Open. Roger.
London VSPP open. Ignition arms armed. Cryons are armed.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 1, plus 2,
S200 ignited,
plus 3,
vehicle lift off.
plus 4, plus 5, plus 6, plus 7, plus 8, normal, plus 9, plus 10 seconds.
Just heard the announcement, lift off normal.
Before tracking, plus 15 seconds,
15 seconds into the flight.
plus 20 seconds.
S200.
First stage performance normal,
indicated as
Plus
normal.
25 seconds. Plus
The
30
vehicle
seconds.
moving majestically.
Plus 35 seconds.
Plus 35 seconds is a very critical phase during the atmospheric.
Plus 40 seconds.
40 seconds into the flight.
Plus
Vehicle is
45 seconds.
7 kilometers.
Plus 50 seconds.
50 seconds.
First stage performance normal. Plus 55 seconds.
First stage performance is indicated normal. So we will
Plus
have
1
in the
minute.
next 50 to 55 seconds the ignition of the L110 liquid engine.
Star 1 in main auto.
75
Star 2
seconds.
in main auto.
Vehicle at
P2
18.7 kilometers.
First stage performance normal.
First stage performance normal as indicated by the range operation director. Another 22 seconds we'll have the ignition of the L110 stage, which again is a very important activity. See a very close match with the pre-flight and the flight predictions.
L110 ignited.
Yes, L110
Plus
core
2
booster
minutes.
has been ignited at exactly 114.9 seconds. The vehicle is at an altitude around 51.5 kilometers.
Performance normal.
And L40 ignition and performance has been indicated normal.
S200 separated.
We heard the announcement S200 solid Strapan has
Plus
been
2 minutes,
successfully
30
separated
seconds.
at 141.2 seconds and vehicle has entered the closed loop guidance in the second phase of flight.
The S200 solid rocket boosters each carry 207 tons of propellant burning for 130 seconds before being jettisoned. The liquid-fueled L110 core stage ignites its twin VECAS engines 114 seconds after liftoff, while the SRBs are still burning. The core stage then burns for 203 seconds before MECO or main engine cut-off and jettison.
Right now
Plus
we are
3
at
minutes.
180 seconds and the altitude is around 95 kilometers.
L110 performance normal.
And we again heard the announcement of the normal performance of L110 stage. As per the nominal sequence, at 224 seconds, we should have the separation of the heat shield. So we are at 200 seconds, altitude 105 kilometers, and very shortly we'll hear the announcement of separation of the payload fairing.
L110 performance normal.
As far as the range of the vehicle is concerned, it's almost traveled 200 kilometers from the launch base. It's an altitude around 117 kilometers, and heat shield has
Heat
been
shield
successfully
separated.
at 225.7 seconds. As far as the velocity is concerned, we have almost a 2.5
Plus 4
kilometer
minutes.
velocity has been imparted to the vehicle. The final injection velocity is order of 9.8 kilometer per second. The next important event will be the separation
L110
of
performance normal.
L110 ton separation, which should happen at 320 seconds. As I was mentioning earlier, L110 ton stage uses the Vikas engine, which is being used for L40
Plus 4
stages of
minutes, 30
GSLV, the
seconds.
liquid strap-on boosters, the second stage of GSLV, and the second stage of PSLV as well. But the duration here is almost for 200 seconds, as against 145 to 150 seconds being used for the
L110 performance
PSLV.
normal.
So L110 ton stage performance is indicated as normal, 3.5 kilometer per second, range of around 410, and very close
Plus 5
match of the altitude and the velocity as a function of time during the S200 and L110 phase of flight. So we should hear the announcement of the separation of the L110, after which, yes, L110 tons
L110
has been
separated.
successfully separated
Commanded.
and 318.6 seconds, and C25 ignition has been confirmed at 325.4 seconds. So C25 ignition has been confirmed
Pre-ignition confirmed performance normal.
and range of almost 633. So this is a very important announcement of
6
successful
minutes.
ignition of the cryogenic engine for the first time in the flight, and the performance being indicated as absolutely nominal for this mission. As you are aware, in the GSLV Mark III, the earlier flight which was done in December 2014, we had only the S200 and L110 stage and the passive C25 stage. So this is the first flight
Pre stage
where
performance
the
normal.
active cryogenic stage is being flown for the first time. And just now we heard the announcement, the C25
Plus 6
performance
minutes,
is normal.
30 seconds.
So we'll have a burn time of almost 600 plus seconds into this flight. As per the nominal sequence, we should have the C25 shutoff command being issued at 964 seconds. We are roughly around 400 seconds into the flight.
The GSLV Mark III C25 upper stage then ignites its single cryogenic liquid hydrogen and liquid oxygen fueled C20 engine for a 642 second burn, successfully bringing the payload into its geostationary transfer orbit 15 minutes and 45 seconds after launch.
In fact, if you look at the velocity that is being delivered by the cryogenic stage during these 650 seconds of burning, almost 50% of the velocity required for injecting the satellite GSAT-19 into a GT orbit will be imparted by this very important cryogenic stage. This is C-25 is the heaviest cryogenic stage ever built by ISRO so far. If you may recall, for the GSLV, we have used a 12.5 ton of cryogenic engine with a thrust of only around 7.5 ton. However, this particular engine, which uses almost 28 tons of propellant, generates a thrust of nearly 18 to 20 tons. 4.6 kilometer per second. So another 5 kilometer per second velocity needs to be imparted. The actual velocity at the time of cryogenic shutoff should be 9.8 kilometer per second relative velocity. There's a continuous increase in the velocity during the C-25 stage. 510 seconds into the flight, velocity around 4.9, and the vehicle has a downrange of 1,330 kilometers, and it has reached an altitude around 233 kilometers now.
Cryo stage performance normal. Cryo engine shut-off.
So C-25 engine shut-off command has been issued at 9:45. The vehicle is at an altitude of almost apogee of 35,000 by 170, minutes. And the GSAT-19 has been successfully separated. Just now we heard the announcement, GSAT-19 communication satellite has been successfully separated at 960.8 seconds.
The GSLV Mark III's first flight back in December 2014 was a test run for the rocket's core stage and strap-on boosters. It used a dummy upper stage because of delays in developing the C-25, and it flew on the ballistic trajectory carrying the Crew Modular Atmospheric Re-entry Experiment, a scaled-down prototype of India's proposed new manned space capsule, which will eventually allow the subcontinent to send its own astronauts into orbit. That 2014 mission was designed to test the re-entry and splashdown capabilities of the new capsule. As for this month's GSLV Mark III flight, it carried the Indian-built GSAT-19 telecommunications satellite into orbit. The new spacecraft acting as a technology testbed for India's new modular 16K satellite bus. The new satellite uses experimental ion thrusters for orbital maneuvering and stabilization, active thermal control using thermal radiators, a miniaturized inertial reference system, and C-band traveling wave tube amplifiers. Development of the GSLV Mark III began in the early 2000s, with the first launch originally slated for 2009. Delays to the program have centred around the Indian-developed cryogenic upper stage and the failure of a Mark II GSLV back in April 2010. To find out more about the new rocket, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
We're going to look at one of the more recent arrivals into the space race, that of the nation of India, and it looks like they've had some success.
Indeed they have, Andrew. They've launched the first mission of their new heavy lift rocket, which is a rocket with the name of Geosynchronous Satellite Launch Vehicle Mark III, which they abbreviate to GSLV Mark III. So it's a big rocket. The liftoff launch weight is 640 tons, which doesn't mean much to you and I, but it does when you put it in a very Indian context, which is to say that is the equivalent of 200 elephants.
Yeah, that's an official measurement.
That's an official measurement. That's right. Yeah, it's a heavy lift vehicle, and a great credit to India, the Indian Space Agency, who have masterminded this and set this project into action and given themselves effectively a very useful tool for lifting geostationary satellites into orbit. Now, geostationary satellites, remember, are ones that orbit around the Earth in the same time as the Earth rotates, namely 24 hours, and so they seem to sit above the equator at the same point. And they're used very frequently for broadcast communications, for internet and data communication. They are very much the workhorse of the communication industry, the space communication industry. We use them all the time. We might even be using one as we speak, although it's doubtful.
Never know.
Sydney to Dubbo, you never know. There might be other ways of doing that.
Well, we do have a massive Vodafone satellite Earth station here in Dubbo for global communication purposes.
There you go. That's right. So that's what these Earth stations are looking at. And of course, if you want to improve your coverage, what you need is more satellites. The Indians recognize this. They did not have a vehicle that could launch a heavy spacecraft up to geostationary because they've got to go up to 36,000 kilometers. That's the height of geostationary satellites, a long, long way. So the GSLV Mark III can do that, and it can do it for a payload of up to 3 tons. And 3 tons is a very significant mass for one of these geostationary satellites. So it's all credit to the Indians. They've done a great job. And I think this vehicle also feeds into India's aspirations towards being the 4th nation to have astronauts in orbit around the Earth. They would like to follow the United States, Russia and China as being the 4th spacefaring nation in terms of getting humans into orbit. And I bet they will too.
And before anyone says it, yes, there have been other nationalities in space, but they haven't been the country
that's right. That's correct. Yeah. Yes, that's correct.
So just to clarify that. For the record, 200 elephants is the equivalent to the weight of 5 jumbo jets.
Actually, I didn't mention that because I thought I would have guessed about 2 jumbo jets, but I might be wrong there.
Well, look,
it's a long time since I weighed a jumbo jet.
Never let the truth get in the way of a good story.
No, of course, that's right.
That's the motto of journalism in the modern era.
Absolutely, yes.
And also, I'm sure you already knew this, but the Indians, they blasted off a big rocket, but it's by no means the biggest ever. NASA still holds that record with the Saturn V.
Yeah, that's right.
Which is enormous. I've been under one. Yeah. I mean, they are extraordinary.
I think the Saturn V is something like 3 or 4 times more massive than this monster Indian rocket. The Saturn V still holds the record of the total liftoff mass being very massive indeed. About 4 times, in fact, what the GSLV is.
It was a lot of effort to get 3 people off the ground, really.
Yes, that's right. It was it's where they were going. That's the trick.
Yes, exactly right.
Magical stuff.
All right, well, good luck to India. We'll watch with interest, but it's great that there's another player in the game and that they've had success with the supermassive elephant rocket, and we'll keep an eye on them.
Absolutely. Sounds great.
That's Dr. Fred Watson from the Australian Astronomical Observatory. He was speaking with Andrew Dunkley on our sister show, Space Nuts. And this is Space Time. I'm Stuart Gary. When people talk about the Earth being flat, most educated people know they're joking. After all, the concept of a spherical Earth dates back well over 2,000 years. In fact, Pythagoras spoke about it in ancient Greece during the 6th century BCE. And Aristotle provided clear scientific evidence for a round ball-shaped Earth in about 330 BCE, when he noticed how during lunar eclipses, when the Earth passes directly between the Sun and the Moon, the Earth's shadow is always curved. Then in 240 BCE, the Greek astronomer Eratosthenes made amazingly accurate measurements of the Earth's circumference by recording the angles of shadows in 2 separate cities during the summer solstice. Because he knew how far the 2 cities were away from each other, and he knew the angles of the shadows, he could use geometry to work out the distance to the Earth's centre, and from that to determine the Earth's circumference. Amazingly, his calculations were only off by about 16%, which you've got to admit is pretty good for that time in ancient history. Of course, today all one needs to do is look at images of the Earth taken from space to see the curvature of the planet. So imagine my surprise when, while listening to an episode of Skeptics' Guide to the Universe, I found that there are still people out there who really truly do believe the Earth is flat. Despite all the science, all the photographic evidence, and even the simple sight of ships on the ocean moving from view over the horizon, there are still some people who believe the Earth is flat and that we're all victims of some giant conspiracy. Some flat earthers are motivated by nonsensical pseudoscience, others by religious literalism. Modern flat earth societies date from the middle of the 20th century. But it seems the modern idea of a flat earth originated with a little-known English writer Samuel Rowbotham, who in 1836 began a series of observations along a dead-straight 10-kilometre stretch of the old Bedford River in Norfolk, England. Based on his observations, Rowbotham claimed the Earth was a flat disk, centred at the North Pole and bounded along its southern edge by a wall of ice known as Antarctica, with the Sun and the Moon some 4,800 kilometres above the Earth's surface and the cosmos a further 200 kilometres beyond that. However, in 1870, Alfred Russell examined Rowbotham's work, finding he had neglected to compensate for the effects of atmospheric refraction. And once these effects were included into the calculations, Russell found the curvature of the planet was consistent with a spherical Earth. As for Rowbotham's true motivation, well, that was released in a leaflet he published soon after his original flat Earth claim. The leaflet was titled The Inconsistency of Modern Astronomy and Its Opposition to the Scriptures. So it turns out Rowbotham was nothing more than a religious eccentric who wasn't going to let the truth get in the way of his personal narrative. Proof that fake news has been with us for an awful long time. Aran Segev is president of Australian Skeptics.
Well, the flat Earth people are a fairly modern phenomenon. A lot of people think that in ancient times people thought that Earth was flat, but that's actually not true. The Egyptians about 4,000
proved it, didn't he?
Absolutely. There's evidence from close to 4,000 years ago that people knew that the Earth was round. In fact, they knew the curvature of the Earth with quite amazing precision, considering the tools that they had at the time. So the whole idea of ancients thinking Earth was flat is quite false. Although there were people in ancient times who thought the Earth was flat, but these were not the educated people. And I suppose the same is true today.
I would say, yes.
Yeah, people who are uneducated who think that the Earth is flat.
I take it the modern day phenomena comes from the Bedford River experiments in the UK.
Well, that was an experiment that was conducted by people who were already flat earthers. So they were trying to prove that the Earth is flat. That was not the reason for the fact that they believed the Earth is flat. And of course they succeeded because they didn't take into account all kinds of physical phenomena.
Let's leave the scientific facts out of this.
Yeah. So they basically conducted, they expected a certain, over a mile, there should be a drop in the Earth of about 8 inches. That's what they calculated at the time, which is around about correct. The thing is, there's all kind of other phenomena in the atmosphere that would cause any attempt to measure that to not be quite so straightforward unless you take all kinds of things into account. Sailors have been taking these things into account for hundreds of years, but the people who conducted this Bedford experiment did not, and therefore they proved that the Earth was flat, proved to their own satisfaction.
Why has it persisted? I believe it's growing by about 200 people a year or something since 2009.
Yeah, I think it's mostly something I don't actually believe it's really growing. What I think is growing is the outlets that people have for all kinds of weird things. I mean, we've discussed a few weird things in the past, and
well, not just anyone can put something on the internet, you know.
Well, it's a place for people to gather in their little echo chambers. I mean, the thing is, one of the things that we should be very careful is not to do the same, not to be closed in our echo chambers and only listen to people who agree with us. But definitely these people find each other more easily on the internet. And it may give the impression that this is a growing phenomenon. I don't believe it is. I mean, the reality is that the number of claims that they have is small. The inconsistencies.
What do they believe is the case?
So they believe that the Earth is a disk with the North Pole at the center and with the ice sheets of Antarctica as the perimeter.
So what happens when you reach the ice sheets? Do you fall off the edge?
You're not allowed to go there. That's why Antarctica is off limits.
Who stopped you?
Now, of course, it isn't. but those are facts, which must not be confused into this conversation.
This is where NASA comes into it, I take it. They're the ones who are patrolling the edge.
Yes, so of course NASA is a big conspiracy. All of NASA is basically one organization, one big organization whose sole responsibility is to spread the myth that the Earth is round. They're busy not looking into space, not exploring outer space, but rather faking data to prove to humanity or show humanity the fake information that the Earth is actually round. That is their belief. And it's unshaken and unshakable. They're conspiracy theorists of the highest degree. Like all conspiracy theorists, any evidence against the conspiracy is evidence of a conspiracy, very similar to what we've seen with the moon hoax believers.
And that's a conspiracy, of course.
Absolutely. It is impossible to convince them that the information that NASA provides is accurate. Of course, NASA doesn't bother responding to these claims. It is a fringe theory by any measure.
Well, I was discussing this with my cat the other day, and she assures me that if the Earth was flat, she'd have pushed everything off the edge of it by now.
Any cat would do that. The thing is, there is really one piece of evidence that we need to counter the idea that the Earth is flat, and that is gravity. The theory that flat earthers push is that because Einstein proved that gravity and acceleration are essentially the same.
Same thing, yes.
Yeah, the principle of equivalence.
This is general relativity theory.
This is general relativity, and that's the principle of equivalence. They're basically saying that Earth is accelerating at 9.8 meters per second squared, which is the force of gravity. And that's basically it. So we're just moving up, and it's creating the illusion of gravity.
But then you have a problem with special relativity, because nothing in the universe can travel faster than the speed of light. Only the expansion of the universe itself can exceed the speed of light.
Well, they've concocted an answer to that, which of course is not valid, but the idea is that from our frame of reference on Earth, we can never reach the speed of light. Therefore, we continue to accelerate, but we never reach. To an external observer, we seem like we're never reaching the speed of light because we slow as our mass grows, as the energy required to accelerate us grows. So
it's interesting the way they'll use some pieces of physics that suit them, and they'll incorporate that into their myth, but other bits of physics, which are every bit as legitimate, they dismiss if they don't fit the narrative they're trying to establish.
Well, that's the whole idea. You use whatever is required to prove your pet theory. That's what conspiracy theorists do. That's what cranks all over the world do. This is not unique to flat earthers, and it's very difficult to argue with them because they use logical fallacies. You may remember the technique that I mentioned a few weeks ago with the Gish Gallop, where you throw facts at
it's like a
your opponent.
Approach. If you throw enough facts, you can't answer every single one of them. We're not computers. You've got to research that stuff, and some of it's going to stick.
Yeah, well, more importantly, I would say it's not just that you can't know. Even if you know everything, it's very easy to raise a question with a few words. It's a lot more difficult to provide an answer with a few words. So what happens is that the opponent comes out as boring and not much fun, and of course in a debate that is a very successful technique. But they really don't have much more than that.
Whenever we speak about these sort of things, and we've talked about UFOs, we've talked about moon hoaxes, my question always remains the same. What's the motive?
I think it's just the semblance of control. You know something that other people don't know. You have some insight into something. What you find very often with flat earthers is that they would speak using scientific terms, which they very obviously do not understand. But they feel, for themselves, they feel like they speak with authority, with knowledge. It makes them feel good about themselves. And I think that's probably the main motivation. I really can't think of anything else because there's no benefit. There's nothing that you earn from it. I mean, nobody sells any books about flat Earth. I mean, maybe some websites here and there that make some money from advertising, but I don't think they make a lot of money. I think it really is about feeling special.
Earlier you were talking about logical fallacies. Exactly what does that mean?
Logical fallacies are basically poor arguments. So let's imagine that you want to prove to me that something is correct. You will try to provide the best information. You will try to provide the best sources, the best resources, to show me that the information that you provide is correct. However, sometimes you might fall into something that seems to you like it's convincing, but does not actually prove your claim. You might, for example, say that you don't believe that we went to the moon because you can't think how it would have been possible in 1969 for us to go to the moon. That argument is not valid. That argument only says that you can't imagine how it would have been done. Maybe it's a failure of your imagination. It's something known as the argument from personal incredulity. I don't know how this could have been done, therefore it wasn't done. But that is not a convincing argument, clearly. That is something that it simply says that you don't know how it could be done. It doesn't say that it can't be done. It doesn't say that other people can't think how it could be done. An important point about these informal logical fallacies is that they're evidence of bad argument, not evidence of a false claim. So, for example, you could make a bad argument about something that is actually correct. So it's very important not to take these logical fallacies as evidence that the other person has necessarily lied or got it wrong. It's only evidence that their argument is poor and that it doesn't prove what they're trying to prove. So, for example, a very common one in politics is the ad hominem. Ad hominem means to the person. Basically, instead of attacking an idea, you attack the person who makes the idea.
But that's great for political point scoring.
It's great for political point scoring. It is very poor arguing when you try to actually make your point from a scientific or logical perspective. Another type of argument, which is in some sense the opposite, is argument from authority. Basically, some famous scientist makes a point. The point may be true or not true. You don't investigate whether the point is true or not. You do not look for the evidence. You don't look at the sources. What you say is, famous scientist said that it's true, therefore it must be true. A lot of cranks actually use that, for example, when they say that Einstein believed in God, because Einstein mentioned God several times. The God that Einstein mentioned is not the God of the Bible.
It's the God of physics.
It is not a personal God. He mentioned God in a more of a colloquial sense. But importantly, for people who want to show that scientists believe in God, because it somehow strengthens their position, they will say that Einstein believed in God, and somehow that strengthens their position question of that God exists. Of course, it doesn't, because Einstein was a great physicist, but he was not an expert on the metaphysical. So whether he believed in God or not, he probably didn't, but whether he believed in God or not is irrelevant to the question whether God exists or not. Another type of logical fallacy is begging the question. Begging the question isn't raising the question. Begging the question is assuming what you're trying to prove when you ask the question. A funny and very well-known example is asking, when did you stop beating your wife? That, or in the question itself, you've already embedded the premise of your question. And that's what begging the question is. Another logical fallacy, which I like because it's easily identifiable and a lot more common than people think, is no true Scotsman. It's also a funny name, I suppose.
No true Scotsman would drink that flavoured milk or whatever.
Yeah, well, the idea, you can say, no Scotsman would ever do something like that. And you say, well, Bill is a Scotsman and he did that. Well, Bill's not a true Scotsman. No true Scotsman would do that. So the idea is that you exclude all of the evidence that proves you wrong and you're left with the evidence that proves you right.
How is that different from moving the goalpost?
There is an element of moving the goalpost in No True Scotsman, but what happens with moving the goalpost is that every time that you're contradicted or you're proven wrong, you shift your argument just a little bit so that your opponent has a new burden of proof. Moving the goalpost is usually something that's done when you're trying to shift the argument to the other side. You want to make the other side work harder in order to establish their position. You ask them a question about your position. Well, how do you explain this? They explain this. You move it just a little bit and you say, oh, well, but if this is true, then how about that? You keep challenging them with things that are more and more distant from the original claim, but you still create a situation where they're actually not. They seem unreliable or they're not actually able to refute you in totality. Another fallacy that is very common is the straw man fallacy. Your opponent has an argument which is difficult to refute. What you might do is build an exaggerated or caricature of their argument and then destroy that. So rather than destroy the original argument, you would basically be building something strange and funny which somehow resembles in some way the original argument, and then you would refute that. It's obvious why it's called a straw man, and it is, again, a very common logical fallacy.
We've been talking about logical fallacies. What's the fallacy?
That is the fallacy that we want to be careful of. That, people who actually are aware of logical fallacies and who spot them easily in other people's argument need to remember two things. First of all, everybody makes logical fallacies. As careful as you might be, you will occasionally stumble and make logical fallacies. That does not necessarily mean you're wrong. As I pointed out earlier, logical fallacies are a sign of a bad argument, not of a false argument. You could be right and still make a bad argument. You could be right and still explain something incorrectly. You could be right and still phrase yourself improperly. That does not mean that the idea that you're promoting is wrong. So the fallacy is, oh, he made a logical fallacy, and therefore his idea is wrong, and that is not correct.
That's Iran Segev, president of Australian Skeptics. And once again, full credit and deep respect to the Skeptics Guide to the Universe, whose excellent report inspired us to do our follow-up. Fans often ask which podcasts I listen to, other than SpaceTime and Space Nuts, of course, and there are quite a few on that list. But there are two which are so outstanding I'd never ever miss an episode. The Jodcast from the astronomers at the Jodrell Bank Radio Telescope near Manchester, England, is a definite must for any hardcore astronomer. But beware, you'll need a reasonable tertiary science background in order to get the most out of the show. The other is the Skeptics Guide to the Universe. The rogues of the SGU give you a humorous and very cleverly written program that's full of important and topical scientific issues. There's a special focus on science-based medicine and the fraudsters, charlatans, snake oil salesmen and just plain con artists who are trying to pull the wool over your eyes and in many cases get the cash out of your pockets. So if you're listening to us in the Northern Hemisphere, take a bit of time out during your summer break to have a listen to the Jodcast and the SGU. And for our listeners in the Southern Hemisphere on those cold winter nights, why not check out the SGU and Jodcast? And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.